Okay, so we're still going over some vocabulary, but we're going to also focus on bringing back domain and range of but specifically for quadratic functions. Let's recap what domain and range are. Domain are all the possible x values. Okay, so when I'm thinking of the x values, I'm scanning my pencil from left to right, okay, along the x-axis. So I always tell my kids, how far left does it go? How far right does it go? For the range, we're talking about the y values. Sorry for the handwriting. Which means we're going to go from low to high, okay, along the y-axis. So I ask my kids, how low does it go and how high does it go? Now, to be quite frank, when we're talking about quadratic functions, the domain, if we're not given any constraints, which means like boundaries, the domain will always be all reals, okay? It's mainly when we get into the word problems that we see the domain is affected, but for the purpose of today, you should just know that domain 100% of the time is going to be all reals. It's the range that's going to have more specific boundaries because it has a low point or it has a high point, a stopping point, okay? Now, let's go over some vocab. So number one, the first equation is x squared minus 2x, which they gave me a graph, which your assignment will also. So let's recap. The vertex, okay, is that minimum or that maximum. In this case, it's the minimum. And the vertex here would be 1, negative 1, okay, as a coordinate. The axis of symmetry is that vertical line that goes through the vertex, and it's always going to be x equals, it crosses the x-axis at positive 1, so it's x equals 1. Okay, so your assignment is going to have axis of symmetry in the vertex, and it's going to have domain and range. So my domain, remember, is left to right. How far left does it go? Even though I can only see this snapshot of this graph, you have to remember that these are arrows, which means it's going to go forever and ever and ever to the left and forever and ever to the right. So if it's forever and ever to the left, that's negative infinity less than x less than positive infinity, because it's going to go forever to the left, forever to the right, and it's going to be less than or less than, not less than or equal to, because it doesn't have a stopping point. And since it's negative infinity to positive infinity, we use the shortcut all reals, okay? Now the range is low to high. Low to high. So how low does it go? On the y-axis, it goes as low as negative 1. Since it touches and bounces back, it's less than or equal to y. And then how high does it go? It's going to go on forever and ever up. So that means positive infinity and less than, okay? So you need to get in the habit of writing the inequality. So remember, if we can remember, okay, we're going to use less than or greater, or sorry, just less than. We're going to use less than whenever it's an arrowhead or an open circle, okay? We're going to use less than or equal to whenever it's a closed circle or it touches and bounces back, okay? Number two, my axis of symmetry is where it goes through the vertex, that center point. This is it's always going to be x equals, and it's x equals negative 1 this time. The vertex is either that minimum or that maximum. In this case, it's the minimum. And this vertex is negative 1, negative 3, okay? Domain, like I said on your problems today, it's going forever to the left, forever to the right, so negative infinity to positive infinity, which is just all reals if you want to use a shortcut, okay? The range is low to high, so how low does it go? Would be negative 3. It touches and bounces back, so it's less than or equal to y. And then how high does it go? It's going to go forever and ever up, so parentheses, positive infinity less than, okay? Number 3, axis of symmetry is where it goes down the vertex. So in this case, it's x equals negative 1 again. The vertex this time is a maximum, because it's the highest point, and this is negative 1, 4, Okay. Now, domain, again, how far left to how far right? Keep in mind, these are arrows. So it's going to go from negative infinity to positive infinity, which is all reals. How low does it go? So how low does it go is forever. So that's negative infinity. And how high does it go? It goes to 4, but it touches and goes back. So it's less than or equal to. Okay. Number 4, the axis of symmetry is where it crosses, that vertical line crosses the vertex. So this time it's x equals 2. The vertex itself is a maximum, so it's going to be 2, 1. Far left to far right is negative infinity to positive infinity, or all reals. The range, how low does it go? It's going to go forever and ever down. And how high does it go? It's going to go as high as positive 1. It touches and bounces back, so it's going to be less than or equal to 1. Okay, just some more practice. Number 5, axis of symmetry is where it crosses that vertex. So it's x equals 1. The vertex itself is that maximum here, so that's 1, 2. The domain is negative infinity to positive infinity again. Unless we start talking about word problems, then it'll have some parameters. So all real. The range, how low does it go, is forever and ever down. And how high does it go is to 2. And since it touches and bounces back, it's less than or equal to. Number 6, axis of symmetry is where a vertical line that crosses that vertex. In this case, it's x equals negative 1. The vertex itself is negative 1, negative 1. And it's a minimum, low point. Domain, negative infinity to positive infinity. Oops. Which is the same thing as all reals. The range, how low does it go? It goes as low as negative 1. It touches and bounces back, so less than or equal to y. And how high does it go is positive infinity, so less than. All right, so what happens if I'm not given a visual representation of my graph? This is where we're going to use our calculator and determine all these values. So my equation for number 7, we're going to type it into y equals negative x squared plus 4x minus 2. You just hit graph, and you don't want to zoom out because then we won't be able to see the values very well. So imagine this is just on your piece of paper, and we're going to do the exact same thing. But you have to do it visually. So the axis of symmetry is if I were to draw an imaginary vertical line right here, it would cross the x-axis at positive 2, so x equals 2. The vertex itself, if I can't tell what the vertex is just because I'm having trouble seeing it, then I can ask the calculator to find that for me. How you do that is second trace, and we want to find, well, let's look at it. This is a maximum, so we do second trace, and I want to look for the maximum, which is number 4. It says left bound, so you see how my cursor is on the left side of the maximum, so I hit enter. Then it says right bound, so I have to be on the right side of the maximum, or the hill. And then I hit enter a third time. And then it says the word maximum, and we're going to round this, okay? So even though it says 1.9999999, it's going to round to 2. But my vertex is 2, 2, my x and y value, okay? And you could have seen that visually. It's just for more accuracy, we're going to try the calculator method. Now, my domain and range. My domain is left to right, which is negative infinity to positive infinity, because we're not given any parameters, or all reals. My range, how low does it go? It's going to go on forever and ever and ever, so negative infinity, or less than y. How high does it go? That y value is 2, and since it touches and bounces back, it's going to be less than or equal to 2. Number 8, we're going to go back to y equals 2x squared minus 4x minus 2. We're going to check out the graph again, give it time to load. All right, my axis of symmetry is if I were to draw an imaginary line down the middle, it would be x equals 1, okay? My vertex is a minimum this time, and if you can't tell what that coordinate is, we can tell my calculator to do that for me. So second trace, it's a minimum, not a maximum, so number 3. It says left bound, so just make sure your cursor's on the left side of that minimum. And then it says right bound. Make sure your cursor goes to the right side and hit enter. Then it says guess, so hit enter a third time. And now it says the word minimum. Again, we're just going to round. So my vertex is 1, -4. Okay. My domain, left to right, is -infinity to a +infinity, or all reals. My range, how low does it go? It goes as low as -4. Since it touches and bounces back, it's less than or equal to y. And how high does it go? Is infinity less than. And yep, there you go. Okay, 2 more, just like this. So y, -2x squared minus 8x minus 5. We're going to graph it. Okay. My axis of symmetry, if I were to draw an imaginary line vertically going through that vertex, it would be at x equals -2. The vertex itself, this time it's a maximum, so I'm going to do second trace 4 for maximum. I need to be on the left side first, enter, then on the right side, enter, then enter a third time, till it says the word maximum, so my answer is -2, 3. The domain left to right is -infinity to +infinity, or all real. And then my range, how low does it go? That's -infinity, because forever and ever down. How high does it go? That's +3. It touches and bounces back, so less than or equal to. Last one, x squared minus 2x plus 5. Graph it. My axis of symmetry, if I were to draw an imaginary line, it would go through x equals 1. The vertex this time is a minimum, so second trace 3 for minimum. Make sure you're on the left side, enter. Then go to the right side of the vertex, enter. And then enter a third time till it says the word minimum. And my answer is 1, 4. Domain left to right is -infinity to +infinity. The range, how low does it go on the y-axis, is +4. Since it touches and bounces back, it's less than or equal to y. And how high does it go is +infinity less than. Okay.